Okay, here we are. We're going to take a closer look at some of the friction stuff that we had talked about before. And so this is me getting everything set up. We can see some of the samples that we used in our activity in class over here. For instance, we've got the felt right here. This is the synthetic material that I described where it's similar to denim, but not really. So this is very similar to the type of material that you would have in most of the clothes you wear. This is burlap. We've got that red craft foam right over here. And then we've also got really rough sandpaper. Do I have the grit? No, I don't. Made in Canada. This is the pretty rough one. This is the much finer one. I'll have to look up which one's which, but I can get that information. And so, but we've got two different types of sandpaper. Now what I've done is I've taken them and I've put them here on this guy. In fact, I'll go ahead and lift this up. We can see we've got the red craft foam there, the finer sandpaper here, the rougher there. There's the felt. This is the clothing type material, and then burlap in the middle. Hopefully that was mostly in focus. Autofocus is never really that reliable. Now I've got this on a stand, as you can see. This is about to go into our one of our electron microscopes. Now this metal bracket that we have here is actually something that we use to make certain that none of the things we're going to look at are going to bump up against our detector, because that would be double plus ungood. So I've got those stuck down with some special conductive tape. Let's take a look at the scope itself. This is Hitachi's TM3000. The TM is for tabletop microscope, and I'll go ahead and bring this around. It is a scanning electron microscope. This guy is designed more or less to be portable. Right now none of the high voltages are on, so I can lift this up here. And that's this shiny guy right up here is, right there, is the what we call electron gun. It's the source of all of the electrons that make this work. It actually fires electrons down a column, down into here. This is the specimen chamber. I'll go ahead and open this up. It is evacuated. Or not evacuated, I mean vented. I'll bring this over. Hopefully we can get a view inside. Alright, so this is our specimen chamber. I have little knobs on the front here that when I turn them, I can actually make this thing in here move ever so slightly. You may not be able to see much of it going right now, because you have to turn it a whole bunch. You can see it spinning here to get it to move just a little bit. Mostly because this thing's designed to be zoomed way in. I'm going to take our samples here and load them into the device. I need to lock the sample stage in place. Now, as I always do, I watch as I close the sample chamber and make certain that my samples don't hit the detector. That's what that bracket shows me, but never hurts to double check. Right over here, this is our evac/air button. Right now, we've got a light that's kind of hard to see up here. It's a green light telling me that air. It's telling me that the sample chamber is fully vented and at atmospheric pressure. When I hit this button, it's going to switch over and it's going to start pulling the air out of this sample chamber so that we can look at it with the electron microscope. I'm going to do that now. You can see it switches. Now we've got a blue light flashing underneath evac. We are currently doing a cycle on our sample chamber here. What's happening are, right now, there's a low power pump that's pulling a bunch of the air out of there. And here in a minute or two, we're going to hear a higher powered pump kick on inside the scope itself. It'll sound a little bit like a jet engine. In fact, it's starting to warm up now. The roughing pump that we have, which is the first one that kicks on, is a little diaphragm pump. It's on the back side of the scope. And then inside the scope, we have something called a turbo pump. It's kind of like basically a little jet engine that we use to help pull all of the air out of here to get it to a position where we can actually look at things with an electron microscope. Now, One of the final things that I'll show you with this setup on the video, I'll bring it around. We've got a computer here and the interface is open. I'm actually going to switch over and try and record that computer interface on the computer itself. But this gave you a way to look at the scope itself, what we're physically loading the things into, and now we'll switch over and see what we get from the scope. Okay, so here we are inside the software controlling the Scanning Electron Microscope. You can see it says Hitachi TM3000 because that's the microscope we're using. Right now, I've already moved the scope in and I've been playing around with some stuff to get my bearing and figure out exactly what I want to cover and take a look at. Now right now, I'm going to zoom all the way out as far as I can with this microscope, and what we're looking at is a 25 times magnification of that red foam. We're going to start off in that craft foam, which is the sort of thing that if you put it in your hands, it may feel kind of smooth, but we're going to see how that holds up. Now I'm going to zoom in a little bit. With a couple of clicks, I can go up to 40 times magnification. Here's 50, 60. You can see already things are starting to look a bit different. Now, right now I'm in a different imaging mode, so what you're seeing may not necessarily be a good indicator of what the surface looks like. So what I'm going to do is, I'm going to go up to 100 times in fact, and I'm going to switch this over to what's called topographic mode. Basically, it's something that kind of gives us a decent idea of what the surface looks like. And we can see in this craft foam, if I go back down to 25 times, here's our craft foam. This isn't the best brightness contrast, but I'm going to wait until I zoom in on it. Here's 30 times, 40, 50, 60. Now this is pretty similar to what we saw in class. I told you that with the optical stuff, the easiest thing to see were bright parts. I told you that those were little tiny hills. Now with the electron microscope, because of the way it picks up its signal, we can actually see all of those little tiny hills much more clearly. We see them, this looks a lot like the surface of the moon, for want of a better term. There are a bunch of little craters. And so I'm going to put this back to fast. I'm not going to give you a full rundown of everything that I'm doing on the scope, because that would sink a lot of time into that. So you're going to see me doing a couple of different things that I may not explain. There's stuff related to making the scope work, but I'll try and describe at least some of what I'm doing as I go. So this is 200 times. This should be a little above what my actual optical microscope could see. And we can still see very clearly, we can see that, hey, there are a lot of little tiny bumps, little ridges all over this thing. It's nowhere near as smooth as we thought it was. I'm going to go back up to fast. And let's play around with the entire reason to have electron microscopes. Let's go up to 1,000 times magnification. And so I'm slowing this down so that we can get a clearer image. That's why it's taking so long for it to fill in. But we can see all of these little ridges up close. We've got ridges along here, little bumps, spiky parts here and there. We can see why this foam, even though it may feel smooth to our fingers, is actually got a lot of friction to it. Another reason that it gave so much friction is because it actually has some give to it. You put something heavy on it and it'll sink down into it a little bit more. So it's not best modeled by our equations for friction. But this gives you an idea of what it looks like close up. And because normally this question is the one that comes up, how high can we go on this? Let's see, fast. I don't know if I'm in focus. About 10,000 times is about the best we can get if we're lucky. Partly that's because of that air handler behind me. Let me see if I can focus this a little bit more. It's probably about the best I'm going to get. On a good day with a good sample, I can get you a pretty good image at 10,000 times. For the most part, not so much. We could have this set up a lot better in a room with fewer noises, because the vibration of noise actually helps throw it off. And then on a better table as well. But it works pretty well for the things that we want to look at in a hurry, so that's why we stick with it here. Okay, so the next thing we're going to do is we're going to move over from the craft foam. We're going to take a look at the synthetic fibers. I think it's primarily nylon, I'll have to check, maybe it's polyester. But I remember it being pretty much synthetic, and so basically they're polymers, they're things that are made with chemistry. And they make little smooth fibers. I'm going to switch our view mode right now. Let's see what brightness contrast does. Oh, that's not bad. We bring this in. We are not in focus. go through and try and focus this guy. So electron microscopes take some getting used to. I think that's pretty good. Let's go explore. The way this scanning electron microscope works is when I get it focused at really high magnifications, it stays focused pretty much everywhere in between for a given spot. And so what I'm doing right now is I'm zooming in so I can try and get the best focus that I can. That should be pretty good. So I'll zoom back out. So now we're down to as low as 18. I'm going to zoom in a little bit. And we can see what we saw before. We can see all these little fibers that are wound together in tiny ropes, and then the ropes are then wound in amongst the other ropes, woven I should say, into the fabric we see. Here's 60 times, here's 120, 250, so this is a bit better than what we saw with my optical microscope. And we can see all these little tiny fibers lying together. They've got some space between them. They don't lay completely flat, but there are little strips there, so you can imagine that while there's some friction, there probably isn't a whole lot. It doesn't look too scratchy. Let's switch over into what's called the topography mode. Here's shadow. I'll go ahead and let that fill in. Some of these, you can see things a bit better than others. We can see little bits and pieces kind of hanging off of them here and there. Shadow 2. So this is the same image, I'm just using different ways of looking at it inside the scope. Here's topographic mode, which is the one that is usually best at telling us about the surface roughness. Now this particular scope is not incredibly sensitive to surface roughness. Let's go up to 1,000 times, let it fill in. So we're zoomed in at 1,000 times magnification on these little fibers that make up the synthetic cloth. And we can see on the edges here that it looks pretty smooth. There aren't a whole lot of little things. Maybe there's a little part that's jutting out right there, maybe one there, a little bit here and there, but for the most part, it's pretty smooth. So, go back to fast, zoom back down to only 200 times. Let's take a look at that. We can see that for the most part, most of the friction is probably going to come from these little fibers not laying really close to one another, tightly packed, because the fibers themselves are pretty smooth. So I'm going to zoom all the way back out. I'm going to switch back over to compositional mode because that's easiest for me to move around with and see what I want to see. Let's go on to take a look at our burlap, which I've got one little thread of it there in the middle. And so that's one of the things that, if you remember, was put with ones just like it into that weird cross pattern. They were woven. So let's go in there. I've got a little bit of the felt coming into the screen, so I'm going to move away from that some. This is the felt down here. Up towards the top is our burlap. I'm going to zoom in a bit more on that. We've got little bits of other stuff on there. Looks pretty good. My app is slightly out of alignment. That's okay. Fast. Slow. Let's take a look at this at 1,800 times magnification, almost 2,000. I think this blurry thing in front here is another fiber that's up high. I'm focused on the one behind it. We can see a little bit of stuff there. Let's switch our image mode. Let's see a little bit of roughness there. Zoom in a little bit more. We're now at 2,500 times magnification. It's kind of hard to see what we're looking for. We can see some roughness here, but I don't think it's helping too much. Yeah, bring this over slightly. Let's get away from that fiber here that's up high. If I go back in to about 1,500 times, slow this guy down. Some vibration there. We can see this guy's kind of rough too. Little bumps here and there. compositional mode. Slightly out of focus, I think. Yeah. When I shift modes, it may also change the focus a little bit, not much, but probably not because it's mostly math done on the detector. We've also got the problem right now that most of these materials are insulators, which means I'm hitting them with little lightning bolts, and they're charging up a lot. That can make them much harder to image. In fact, you can see this part here keeps moving. That's because it's charging up and kind of flopping around because it's trying to get away from the charge. And so, but we can see that up close, these are kind of rough. Kind of split fibers there, they've got sharp edges on them. And they're made up of several different materials. Some of this is pretty heavy, probably metallic, and then the others are probably carbon-based, organic. So if I go down to 180 times, we can see the fibers here. We have some of the felt coming in, that's these little loops down here, but we can see that this guy's not terribly comfortable, as we would not expect burlap to be. I'll zoom out a little bit more, so that we can see all of it together. Another thing about the burlap is these aren't put in very, very close together. They're not tightly woven, and so the ropes kind of hang all over the place. That makes them kind of scratchy. Speaking of things that are a little bit scratchy because they're just kind of all over the place, oops, let me go too fast so I can start moving around a bit more. We're going to go over to the felt, which is directly beneath this. Here's our felt. Take a look on slow. This is mostly in focus, actually, at least for this far out. And we can see that those fibers, they look really smooth, but they're still just kind of all over the place. Felt is a material that's not really woven. You just take a bunch of fibers and you squish them together, and then they kind of stick that way. That leaves a whole lot of open space in between all these fibers. That's one of the reasons why it has so much more friction, because you have fibers in one spot and then open space and then more fibers. It's a pretty rough surface once you get down to it. This isn't smooth at all. So what I'm going to do is we're going to go in, that was 50 times, this is up to 180. We're starting to see it a little out of focus, so I'm going to come in and clean this up some. We're at 300 times now. I'm going to go up to 800 times. Pretty good. 2,500. Probably about there. So if I zoom all the way back out, that's looking pretty good. 100 times, 120, 200. So this is pretty comparable to what we saw with my optical microscope. We can see all those little fibers. They look pretty smooth. They've got some little pieces here and there, but most of the friction is not coming from how rough the fibers themselves are, just that they're not laid on top of each other or in nice ordered ways. Shadow 1. Shadow 2. Basically, this is simulating lights coming from one side or another. And finally, topography, which is usually the thing that we can see the roughness of the samples better with this scope. If I go into 1,000 times, I'll let it fill that guy in. We'll see what we get. So we can see there's still some charging going on here, but we've got little bits and pieces that kind of stick off of them, but for the most part, in fact, my guess is this felt is actually made from a synthetic material very similar to the other ones that we looked at. So this is a polymer that's made chemically, and that's why it's so smooth, and they take them and they squish them all together. Felt can either be natural fibers or artificial ones that are made basically with chemical processes. And so my guess is this is probably a synthetic, an artificial fiber, something that was made in a lab or a factory somewhere. That's why it's so smooth. And going back over to compositional mode. In the different modes, we can usually pick up on different things. And so now what I'm going to do is I'm going to zoom this guy back out. I'm going to go go back to fast mode so that I can move quickly. We're almost done. We're going to take a look at some of the sandpaper. And the sandpaper looks pretty funny in this microscope. Part of it is not doing so well under the vacuum and the lightning bolts, little tiny lightning bolts that we're shooting at it. That's how this microscope works, hence the electron in the name. It's actually cracking this sandpaper quite a bit. We can see these cracks developing in here. I'm going to zoom in and try and find one so I can get this focused. And this one in particular, we're going to want to use the topographic mode so that we can actually get an idea of what the surface itself looks like. So 500 times, this is 1500. That's out of focus, that's out of focus. There we go. Center that a little. So if I take this down to 50 times magnification, we can see that there are a whole bunch of cracks in there. It's been picking up more and more cracks since I put it inside the microscope. I don't think it likes the charge, the high temperature that it ends up with because of that charge, and the fact that there's pretty much no air in there. So it's been cracking quite a bit. So if I zoom in, this will be 200, so that's about what my optical microscope saw. Now normally these cracks wouldn't be there, but you can already see there are little parts that are bumped up here and there. The cracks will make it even rougher. But what we want to do is we need to switch over to a different imaging mode so that we can see it a bit more clearly. And I found topographic to be about the best. And so with topographic here, we can see that along with these cracks, we have parts where it's actually physically raised up. We've got parts here and here. There's a bunch of little specks here and here. So if I go in further, and this should be the really rough sandpaper between the two as well, up to 1,000 times. There's one of the cracks. We can see kind of rough material. We may be zoomed in a little too high for this guy to fully see what he's got to offer. Let's see what the shadow mode has. Yeah, not too much around this crack here. If I zoom out, you can still see parts that raise up, lower down. They've been hit with a bunch of cracks now because of the electron beam and the vacuum. Let's go to topographic. Let's go ahead and touch up the brightness contrast, see if that gets us anything. That's not bad. Contrast all the way up, brightness at a mid-range, about what I'd expect. So this is 200 times. If I zoom out a little bit more, 100 times, we can see all the little, not that little, this is actually the rougher of the two, I believe. We can see right here is where, when we saw those rocks, these high points here, that's where those rocks are. We can't physically see the rocks here because the glue that we were looking through that we could see the rocks on the sandpaper, that was clear to light so we could see through it, but it's not clear to our electron beam, so we can't. We only see the surface itself, which is actually a little bit better because that gives us an idea of exactly how rough the physical surface is. So I'm going to zoom out. Actually, let's see what that looked like. And so we can see all the little, zoom this far out, we can see the big rocks comparatively on this guy, and then over here we can see the finer sandpaper. I need to actually see where I'm going on this. I'm going to bring the other sandpaper more centered for us. Right here. And the second sandpaper is probably pretty well in focus too. So we can see each of those little bumps, again, they were the rocks. We can see that they're much smaller over here than over here. Now for the most part, I'm just referring to them as rocks. Sandpaper is actually made out of aluminum oxide, so you don't spam me with a bunch of, hey, those aren't just rocks. But it's an easy way to think about them. I'm going to switch over to compositional mode real quick. And you can see in this imaging mode, we lose a lot of that sensitivity of what the actual roughness of the surface looks like. But for now, I'm most comfortable going in and trying to focus with this setup. and it'll get me pretty close to what I want. So I need some features to look at. That's what these bright things are. Up to 3,000 times here. That's pretty good. Come back out, now that we're mostly in focus. See with the topography mode, topographic. Zoom back in. Let's actually sit around 60 for now. And I'll slow it down. We can see all of those little individual bumps. In class, those look like the little rocks that they had glued down on the sandpaper. You can see that this is actually a pretty rough surface, as you would expect, given that it's sandpaper. Zoom in some more. This is 200 times, so this is similar to what we saw zoomed all the way in on my optical microscope. So we can see those edges coming up. Here are the little tiny particles, the little rock guys that were glued down. This one's probably a bit bigger than the others, but we can see little ridges that are coming up from that. Now let's go in 400 times. So zoomed in twice as much compared to my optical scope. You can see some of the stuff there. Let me, this may take our focus out a little bit, but let's see if we can find something a little bit cooler. So here's one of our rock guys. Zoom in on him up to 1,000. Just a second, trying to focus. Harder to focus in this mode, I think, at least for me. But that should be pretty good. You can see it's kind of like looking at the top of a hill, or maybe even a mountain. You've got kind of sharp edges that come up on a point. You've got little tiny bulges here and there, so we can see, hey, this is pretty rough. Positional mode. That's some of the rock actually underneath that we're seeing down there. Probably silicon showing up a bit more than just the aluminum oxide. Then here's shadow. Let's see if we can get anything a little bit better accented. No, looks like topography's doing the best, at least for this particular setup on this sample. Okay, so that's pretty much all the samples that I have loaded in there. I know it was kind of a long video, but hopefully you enjoyed that. I may try and go in and put some on there related to what we get from the optical scope too. But I had the chance to sneak in and use the electron microscope with authorization, of course. And so I figured people might enjoy that and get a better understanding of why, even if something seems smooth, like our foam, that craft foam that we had, it felt pretty smooth, that it's actually, once you get down close up to it, it can be very rough. It's got a bunch of little bumps and hills all over it. So, okay, well, if you have any questions, let me know.